This conference will now be recorded.
Hello everyone. So in this video, we will discuss previous year's questions of JEE main exam, and that is from the chapters Hydrocarbons. So here we have the first question. There are two statements given, statement 1 and statement 2. So in the light of the above statement, we have to choose the most appropriate answer from the options given below. In statement 1, it is mentioned that nitration of benzene involves the following step. Which following step? This is the step that is mentioned here. And in the second statement, it is mentioned use of Lewis base promotes the electrophilic substitution of benzene. Now, the first statement is related to nitration of benzene, right? In nitration of benzene, what happens? There is benzene, and in presence of the reagent, that is the mixture of nitric acid and H2SO4, one of the hydrogen of benzene ring that is replaced by NO2 group. So this is nitration of benzene. But if you consider its mechanism, the first step that happens, that is the formation of the electrophile. So here this hydrogen is replaced by the electrophile, which is NO2 plus. And how this NO2 plus is generated? That is actually mentioned in this equation. As you can see, here we have HNO3, which is already positively charged. So if HNO3 molecule, if you add one more hydrogen, so there will be basically this positive charge is not on hydrogen, this is on oxygen. So this first consider the normal structure of HNO3. It is like this. Fine. Now if there is one more hydrogen is attached to this oxygen will be positively charged. And where from this hydrogen, that is H plus, is coming? That is coming from H2SO4. So this is the first step where this electrophile is generated. This is our electrophile. It is equivalent to E plus. E plus means electrophile. Now this statement is actually true because that is the first step occurs. So it involves the following step. This statement will be true statement. Now come to the second statement. It is mentioned that use of Lewis base. Now Lewis base means what? Lewis base means any species which can donate electron pair. That is the definition of Lewis base. And if you consider Lewis acid, which can accept electron pair. And there is another concept of acid and base, that is bronze state, where if we say that it is bronze state acid, that means H plus will be given, and if it is bronze state base, it will be accepted. H plus will be accepted. But here it is mentioned Lewis base. But which is the molecule? What is the molecule that actually promotes this substitution? That is actually H2SO4, and it's not Lewis base. That means the second statement is not correct. It is false. Now we will see the detailed mechanism of nitration. This is the first step where HNO3 molecule, this is actually HNO3 molecule, in presence of H2SO4, one H from H2SO4, it is now attached to HNO3, as you can see in this molecule, and HSO4 minus, that is the remaining part. Now from this, if this water part is removed as neutral water molecule, you will be left with this E plus. So this is our electrophile, and this step is actually mentioned in the given question. Now in the second step, this benzene, the pi electron cloud, that will be attracted towards this E plus, and this is actually the electrophilic. It is the addition of electrophile, and because of this addition, this pi bond is broken, there will be positive charge generation, and finally this CH bond will be broken, and in this position there will be a double bond. So this is the full mechanism. But here it is true that that is the first statement is correct, but the second statement is incorrect. So option 2 should be the correct option. Okay. We'll go to the next question. In the above chemical reaction sequence, A and B respectively are. So in the first molecule that is given as substrate, this is cyclohexene with a methyl substituent. And when we are treating it with A, we are seeing that the ring structure is open, right? As if in this position, this CC double bond is broken, and in that position, you are getting 2C double bond O group, that is a carbonyl. Now, if you are having any trouble, just put some numbers. It will help you to understand the change in the structure. 1, 2, 3, 4, 5, 6. Similarly, I will also put number here. So at 1 and 6 position, as you can see, there is C double bond O. That means it is organolysis reaction. where CC double bonds clipped. Now what is happening in the second step? In the second step, this part there is no change, but this part if you see, this COCH3, now it is converted to COO minus Na plus, that means sodium salt of carboxylic acid. Let me put the numbers again. Fine. So this aldehyde part, this is the aldehyde part, there is no change, but this side is basically ketone part. It is CH3CO and then this large group. So this part is ketone. Now come to the options. The first step is ozonolysis with reductive, that is the final step, we use some reducing agent. So it must be either that is option 1 and any of these two options, because this reagent is not possible. It is ozonolysis. So ozone gas must be present with zinc H2 as reducing agent. So this is the first reagent we need to use. So this must be A. So our A is present in option 1 and 4. So these two we can cancel. Now come to the second reagent for B. Here it is mentioned NaOH iodine, alcoholic NaOH iodine, but in option 4 it is mentioned potassium permanganate. Now KMnO4, what is the purpose of using it? KMnO4 is oxidizing agent, that is first. But this type of change that you are seeing here, where COCH3 group is converted to CO2 minus Na plus, this conversion is not done by KMnO4. This is actually iodoform reaction. So in iodoform reaction, what happens? If you have this type of group, that is RCOCH3 group, for R group side it may be any alcohol, or if you have RCHOHCH3. So any of this group if you have, then only this type of, that is this part, it will change to CO2 minus, sodium salt of the acid, because in the medium it is basic. Further, if you do acidification, it can be converted to carboxylic acid. But first, there is sodium salt formation. So this is the general equation. So you can take RCOCH3, you can treat it with iodine NaOH, you get sodium salt. So this is the general way you can write the iodoform reaction. And the same thing is happening here. So we will choose which option? We will choose the first option. Among 1 and 4, we will choose the first option, which is first O3ZnH2, that is ozonolysis, and the second reaction is iodoform reaction, where only this part there is some changes happening, not the rest of the part of the molecule. Next question. Two reactions are given. Look at this. The first reaction is hydrogen plus A. Now, what is A? We do not know. We have to find that. So hydrogen reacting with A in presence of PDC, that is palladium in charcoal. That means we are using metal catalyst in presence of charcoal or carbon. We are getting this type of molecule. Now, one thing is clear from this, that in this reaction, both the hydrogens are added from the same side. And A must be having some triple bond type of bond must be present, because it is hydrogen addition in presence of metal catalyst. So there must be some unsaturation, and from triple bond we are getting double bond. Now come to the second reaction. In the second reaction, a triple bond is already given. You are treating it with H2. In presence of sodium liquid ammonia, you are getting product B. Now B you have to recognize. So in the first case, it is obviously alkyne. So identify A and B. So all these are basically A. That is 2-pen. A will be either 2-pentane or it will be N-pentane. Any of these two you have to choose. Now N-pentane is not possible, because in N-pentane there is no unsaturation and no question of addition of hydrogen. So either you have to choose option 1 or you will choose option 3. So these two we can cancel. Now what will be the structure of B? Hydrogen addition when happens in presence of this type of reagent, sodium in liquid ammonia, it is always trans addition. Okay, so that is the reason. Now we will get what type of structure? Hydrogens will be added from the opposite side, and as a result we will get CC double bond H. So this is trans 2-butene. Put the numbers 1, 2, 3, 4. 2 position there is double bond. and these two groups, they are trans, that is, it is 2-butene. So we have already cancelled 2 and 4. We are stuck between option 1 and option 3. So C is not correct. This one should be the correct option. The first substrate A is substrate in reaction 1, which is 2-pentyne. Let me write the structure. That is the structure of A. It will be like this: 2-pentyne. So at 2 position, there will be triple bond. So it is 2-pentyne, 1, 2, 3, 4, 5. And when both the hydrogens, they are added from the same side. Now CH3, C double bond C. This part will be C2H5. And this is HH. So this is our structure of A. Okay, first option is the correct option. What is the product form in the given reaction? The product form in the given reaction, here cycloalkene is given. You have a ring structure and there is CC double bond present and there is methyl substituent also. So this CC double bond is not symmetrical, it is unsymmetrical. And when there is unsymmetrical alkene and you are adding DCl, now DCl is nothing but the equivalent of HCl. So if you know how to add HCl to CC double bond, it is basically the same thing for DCl also. Only difference is now in place of hydrogen you have deuterium. It's isotope. That is the only difference. But when you have unsymmetrical alkene, you are adding some reagent which is also unsymmetrical. You have to apply Markovnikov rule. And according to Markovnikov rule, what we know, that is a negative part of the reagent. So here the negative part of the reagent is Cl negative. Negative part of the reagent will be added to that carbon where hydrogen number is less. Here we have one hydrogen and other side, that is if it is carbon number 1, if it is carbon number 2, in carbon number 2 you do not have any hydrogen. So Cl must be added to that side. And if it is so, that is D is added to 1 position and Cl is added to 2 position, it must be structure 1. Another alternative is this one, but D will not be added to this part. And then in option 3, both the groups are added to the same carbon. That is obviously not correct. And here, as you can see, as if methyl group is one of the hydrogen is replaced by Cl, but that is absolutely not possible. So maximum you can that is close answers, you can say it is option 1 and 2, but 2 is not correct because according to Markovnikov rule you have to choose this. So this is the correct option, fine. But as I always say that do not always blindly follow, just check once whether, so this is simple reagent, even if you do not consider it is okay. So what will happen, first there will be addition of D and there will be positive charge generation here. If you do the other possibility, then D is added here where methyl group is already present, positive charge is here. Now in this case Cl is entering here and you are getting the option 2 structure, but here Cl is entering here and you are getting option 1 structure, and this is the correct one. Fine. Okay, so next question. What will be the reactivity order of the following compounds towards electrophilic substitution reaction? You have total 4 molecules that all are benzene or benzene derivatives. The first one is simple benzene, and then you have benzene derivative, chloro substituted. Then we have nitro substitution and we have methyl substitution. Now electrophilic substitution, whenever we consider, and let me put all the double bonds, and suppose here we have group G. Now G may be Cl, it may be NO2, it may be CH3. That is, in this, for this question we can consider it like this: Cl, NO2 or CH3. So if you know the electrophilic addition substitution mechanism, what happens first? First the electrophile is added by this double bond, okay, and there is a positive charge generation. Now this positive charge, it can involve in resonance, and the positive charge can be shifted to this position or it can be shifted to this position also. Now what happened after the first step, there is some positive charge, and then in the second step there is some nucleophile addition. But here we have to predict the reactivity order. So when there is hydrogen substitution, that is, if you consider simply benzene, then G is basically hydrogen. So there is no extra effect, we can say. But when there is Cl group present, we know it has minus I effect. But when we consider whether ortho position or para position the electrophile will enter, then we give more preference to plus R effect. But when you are talking about the reactivity order, you have to consider minus, you have to give more significance to minus I effect. So what it means, overall the Cl is decreasing the electron density in the benzene ring. But this is addition of electrophile. So in the benzene ring, if electron density is already decreased, then obviously it will not, its nucleophilic character towards E plus will be decreasing. And that is not desired if you want very good reactivity. So that is why Cl will not, that is, it will, compared to benzene, it will deactivate the ring. That is, it will decrease the overall electron density. Now come to the to group. Now this is very electron withdrawing. It has minus I effect, minus R effect. Very highly electron withdrawing group. So it will be, that is, maximum effect you will get for NO2, where it will decrease the reactivity towards E plus. And what about CH3? CH3 has plus I effect. So compared to hydrogen, that is when you have simple hydrogen substitution, compared to hydrogen, now it will decrease, sorry, it will increase the electron density to some extent. So rate should be maximum for this molecule, that is, which is toluene. And then after toluene, you can expect it for benzene, that is 1. And then it is 2, because it is electron deactivating, but not so deactivating. And this is a maximum deactivating effect. So nucleophilic character for this part, because of the group G, it will be better for, that is, maximum electron density will be for methyl substitution. Then it is simply hydrogen, and these two are deactivating. So that is why after 1 it will be 2 and 3. But between 2 and 3, 2 will come before 3, because it is less deactivating than So option 2 is the correct option. Number of structural isomeric products formed by monochlorination, that means only one time chlorination will happen, 2-methyl butane. We will first draw the structure of 2-methyl butane. So this is butane, 1, 2, 3, 4, and 2 position, there is a methyl group, right? Now when we are talking about monochlorination, that means only one hydrogen will be replaced by chlorine. So here, how many types of structural isomer? You don't have to consider stereoisomer. How many types possible? If you want to know that, you just have to check in this molecule how many different types of hydrogens are present. Now, these two methyl groups are symmetrical. So I can say these hydrogens are type A, both, total 6 A type of hydrogen. So any of these hydrogen when replaced by chlorine, you are getting a type of structural isomer. Then if you consider this hydrogen, suppose it is hydrogen B, you have one B type of hydrogen. Then for these two types of hydrogen, suppose it is C. So you have 2 C type of hydrogen. And again, these 3 hydrogen in the methyl. So 3 types of, suppose it is D type. So all are D. So 3D. So total 4 types of hydrogens are there, A, B, C, and D. That means structural maximum you can get, only structural, not stereo. Monochlorination product possible in presence of sunlight. That is, and the answer should be, it is an integer type of question, answer should be 4. Fine. You don't have to draw the structure, just check the molecule, because if you draw the structure, it is unnecessarily wasting of time. Just look at the molecule and how many different types of hydrogens are there. That just you have to record. The types, depending on types of hydrogen, you will get different types of product. Consider the following sequence of reactions. Here, the first molecule given is CH3C triple bond CH. So there is a terminal hydrogen. Now when you are treating it with sodium, this terminal hydrogen, that will be replaced by sodium. So what you will get? You will get CH3C triple bond CNA. Now this is matching with what? That is, you have to find A and B. Now the first option, all the options, the first structure is for A. So any of these 2 or 3 should be your answer. It cannot be this molecule, because here see total 4 carbons are present, but you have only 3 carbon here, isn't it? In the starting material you have only 3 carbon and you are treating it with sodium. Then where from this extra carbon will come? This is not possible. And then why option 1 is not possible? Because it is triple bond to double bond conversion. That means 2 hydrogens needed, but you are not adding any hydrogen. You have added sodium. So maximum you can get substitution of this hydrogen by sodium. So option 2 or 3, any of these 2 will be correct. Next we are treating it with B. Now you have to find the reagent. In the previous case you have written the product A, but now it is reagent that you have to recognize. Now look at the final product. In the final product, how many carbons are there? 1, 2, 3, 4, 5, 6. Total 6 carbons are there. And in molecule A, there is total 3 carbon. But in the final product, 6 carbon, that means 3 extra carbon you need. Where from the 3 extra carbon will come? The reagent B should be such, that is B should contain 3 carbon. Then only you can get this type of 6 carbon product. Now look at option 2 and 1, because these 2 we have already cancelled. So for option 2, it is CH3, CH2, Cl, 2 carbon only. But for option 3, it is 3 carbon then Cl. That means B must be 3 carbon then Cl. And what reaction is happening here? Basically here negative and positive charge is present. This negative charge, if it is attacking here, this carbon chlorine bond will be broken. So here this CH3 C triple bond C minus, it is as if acting as a nucleophile. So it is attacking this carbon which is containing good leaving group chlorine, and ultimately you will get CH3 C triple bond C, and then this new 3 carbon is coming from the reagent B. And this is the structure given here, that is in the question, isn't it? So option 3 should be the correct option. Okay. Identify product A and product B. We have cyclohexene molecule. We are treating it with chlorine, but under 2 different conditions. When it is condition 1, we are treating it with H nu. It may be sunlight or photoradiation. In the second case, it is CCl4 solvent, that is only mentioned. So when H nu is not there, you can consider it either room temperature or heat, but only solvent is mentioned. So when you have this type of non-polar solvent, you get one type of product, which is product B. And when you are doing the reaction in presence of sunlight H nu, you are getting product A. So 2 different types of products will be there. Both the products are not same. It is true that in both cases, chlorine is the reagent with which the CC double bond will take part in reaction. That is fine. But reaction types will not be same. So when it is reaction 1, product in case of product A, here basically allylic chlorination will take place. Or you can say allylic substitution. Now allylic position is these 2 positions. And in these 2 positions, you have 2 hydrogen. So that those 2 hydrogens will be replaced by chlorine atom. And this is basically a radical type of mechanism. So these 2 positions, there will be addition of chlorine. Basically, it is not addition, it is substitution. Simply, you have substituted the 2 hydrogens with 2 chlorine atoms. CC double bond is still present. So it is obviously substitution, it is not addition. And for the second case, when you are treating any double bond with chlorine in presence of this type of nonpolar solvent, it is simply the addition of chlorine to the double bond. So double bond will now be broken and the 2 new CCl bond will be produced. Double bond will not be intact. That means it should be a product like this. Now look at the options. Here option A, it is basically reverse. Option second option, both the products are same. Third option, both the products are same, but both of the reactions will not generate same product. It is the last option which is the correct option. Okay, because it has correctly recognized the actual products. X is the major product. What are your Starting material is benzene. Then we have this type of ring structure with exocyclic double bond. We are treating it with HF and heat is also there. Now, what type of reaction is happening here? If you have some doubt, what you can do, simply look at the options. Here, as if the two ring structures are connected, right? That means some substitution will take place. Is it substitution or is it addition? Basically, it is substitution, because one of the hydrogen of benzene, that will be replaced by some other group. Now, this other group will be generated by the combination of the second reagent, and also HM has some role. So this is actually electrophilic substitution reaction in benzene. So what is happening here? First, you have to make the electrophile. What type of electrophile generation is happening here? In presence of HF, which is acid, the double bond that is present in this molecule, it will be protonated. Now, when it is protonated, it will capture this H. Now, which after protonation, now we will think that it is not symmetrical alkene. So, which side protonation will take place? Obviously, protonation will be here, because if it is so, then only the positive charge is here. Another possibility is this one, where you are adding the hydrogen here and positive charge is on the methyl group. But which one is more stable? The first one is more stable, because here it is 3-degree carbocation, it is 1 degree. So we will consider this one. Now this is actually our electrophile. So our electrophile is, let me write it again. This is the electrophile. And when you are treating it with benzene, these double bonds will attack here. So one of the double bond is broken and we are getting this new bond. So this is the newly generated bond and positive charge is here. And finally, in the medium, you already have F minus. So this F minus, it can capture this H and H plus will be removed. And this H, it will, before removal, it will give electron density. So there will be a double bond generation. So this structure is matching with option 1. Now, option 1, if it is correct, fine. But why the other options are not correct? Now see, if you consider the second structure is not possible, because it is as if addition, that is, if you consider this molecule and this is here, that means the addition with respect to this hydrogen, it is at 3 position, but that is not possible. Then in option 3 also, with respect to this methyl group, which is basically this carbon, it is at 2 position. That is also not possible. Fine. And here the methyl group, it is as if directly on the methyl benzene ring, but where from the methyl group it will be on the benzene ring. It is not possible at all. Okay. So here this carbocation is maximum stable. So that is why the reaction will be happening through this. And if you consider some rearrangement, which is absolutely meaningless, then the positive charge will be shifted to this carbon, and then addition, you can get option 3 type of product, but that is not meaningless, because why rearrangement will occur? Here you already have stable carbocation 3 degree, so further rearrangement not necessary. Option 1 is the correct option. Butene is reacted separately. So this is our butene with 1 mole of hydrogen as shown below. So here both sides, 2 different sides are there. This is the actual substrate plus H2. But plus H, this is common. But one time you are treating it with sodium and liquid ammonia, you are getting B. Another time you are treating it with PDC, palladium in presence of charcoal, and there is heat also. You are getting product A. Now A and B related statements are given as A, B, C and D. Now among these statements, which statements are wrong, incorrect, that you have to find from the options. So in the options, sometimes it is B and C, that is more than 2 or 2 options, 2 statements are there in the options. Now the statements are related to the products A and B. So first thing that you have to do, you have to write the structure of A. So CH3C111CCH3, when you are treating it with PDC type of reagent, both the hydrogens will be added from the same side. So the structure of A will be Cs. Okay. And the structure of B will be trans, because in presence of sodium liquid ammonia, trans addition takes. Now we will consider the options statements one by one. The first statement is saying that A is more soluble than B. Now A is cis and this is trans. And it is saying A is more soluble. Actually, this is correct statement, because when you consider trans and if you consider the overall dipole moment, these two bonds, they are opposite to each other. So as if even if some polarization generated, they will cancel each other because of this type of structure. But in cis, both the heavy groups, they are on the same side. So more polarity compared to trans we will expect. And that is why it will be more soluble than B. So this is correct statement. Now the second statement is saying that boiling point and melting point of A are higher and lower than B respectively. So higher is for BP and lower is for MP. Now BP for cis greater than trans, that is mentioned here, and MP, now it is reverse. Now is it true? That we have to find. Now cis BP will be high, this is true, because here overall if you consider dipole moment, there is some dipole moment unlike trans. So because of this higher dipole moment, now the intermolecular interaction, that is the interaction between two individual molecules, that will be high compared to trans. And as a result, you have to provide more energy when you are converting from liquid state to vapor state. That is boiling point. So that is the reason boiling point of cis will be high. But why? What about melting point? Is it also true? Now it is reverse. Why? Because when it is trans, this type of structure, what happens in solid crystal, the crystal packing is very good. But when it is cis, because of this type of structure, in the solid crystal, the packing is not very good. Packing is good when you have this type of zigzag type of structure, right? And that is the reason melting point means what? You are moving, changing the phase from solid to liquid. Now solid to liquid, if crystal packing is very good, you have to provide more energy. That means higher MP. So that is the reason trans will have higher MP. But for BP it is reverse. So this statement is also true. What about C? A is more polar than B because dipole moment of A is 0. Now A is more polar than B because dipole moment of A is 0. How it is possible? It is contradicted. So this is not true. It's not, dipole moment is not 0. Actually, B dipole moment is 0 for the trans. So this is not correct. And bromine adds easily to B than A. Now, bromine addition with trans and bromine addition with cis, in which case it will occur easily. Now you have to consider the overall energy of cis and trans. Trans is more stable than cis because of its structure. Now, if a molecule is already in higher energy, it is easier for the molecule to take part in reaction, because when a molecule is having higher energy, that means it is more reactive. So here cis is more reactive than trans because of its higher energy, and it is already have some higher energy. So its reactivity towards hydrogen, it will also be high. So bromine acts easily to B. B is basically trans, A is cis. So bromine acts easily to trans, it is not correct. It will be the reverse, easily to A, then B. So C and D, these two options are incorrect among A, B, C, D. A hydrocarbon X with formula C6H8 uses 2 moles of H2 on catalytic hydrogenation of its 1 mole. So when you have taken 1 mole of C6H8, you need 2 moles of H2. It means what? There must be 2 unsaturation. That is the reason H2 is added. Okay. Now, is it double bond or triple bond? Look at the options. Only in mention. There is no ine. That means we just have to deal with double bond. So this is the ratio. It means what? There must be two double bonds. Two CC double bonds must be there. That is the reason you need 2 moles of H2. So this is the first information. And the second information, on ozonolysis, X is yielding 2 moles of methane dicarbaldehyde. What is its structure? It is methane derivative. Dicarbaldehyde. Carbaldehyde is CHO group. That means 2 CHO group will be substituted in methane. So methane is CH4, but when 2 hydrogens are substituted by 2 CHO group, now the molecule is this one. So when you are doing ozonolysis with this hydrocarbon C6H8, you get 2 of this molecule, 2 moles of this. Now look at the options. Which option correct? That we have to find. It is try-in. Now try-in is not possible according to the first information. This is the first information. This is the second information. It is not possible. 1-methyl cyclopenta 1,4-diene. Let me draw the structure. 1, 2. Okay, it is at 4 position. 3, 4. And at 1 position methyl group. Now here you have 2 double bonds. And the first information is matching that 2 moles of H2 required. But when you are doing ozonolysis, will you get 2 moles of methane dicarbaldehyde? So this is containing 3 carbon and 2 moles you are getting. That means total 6 carbon must be there. This molecule is also 6 carbon. But when you are cleaving these CC double bonds, basically what you get? You get CH3CO, and from this side you get CO, and another side you are getting methane dicarbonate, but it is not same molecules. So this is not correct. Then cyclohexa 1,3-diene. 1, 2, 3. So at 1 position double bond, 3 position double bond. But this is also not symmetrical. The structure must be symmetrical. Then only you can get 2 molecules of methane dicarbaldehyde. Come to the option 4. Option 4 is 1 and 4 position. There is double bond. Now when you are cleaving this, from both sides, from this side you will get methane dicarbaldehyde, from the other side also you will get methane dicarbaldehyde. So it is matching, both the informations are matching with option 4. So in this way, gradually you have to choose the correct option. The first option you can easily cancel because it is having 3 double bonds, not possible. Then the second structure, 2. When you get 2 moles of methane dicarbaldehyde, the structure must be symmetrical, but it is not symmetrical. Same problem with 3 also, 3 option. Only with 4 you are getting 2 similar type of molecules. So when you do ozonolysis, you get 2 moles of methane dicarbaldehyde from 1 mole of C6H8. And also you can check the structure. Here total number of hydrogen, 2 hydrogen in this position, 2 and 4. So it is 8. Go to the next question. Choose the correct set of reagents for the following conversion. So you have trans, PH, CC double bond, CH3, and you will change it to cis. What reagent you need? Now look at the options. The first reagents are same for all. So simply put bromine and try to see what is happening here. So when you put bromine is added, fine. Now the next reagent is either alcoholic KOH or aqueous KOH. This is the second part, second reagent. Total 4 reagents are there in all the options. Now when you use aqueous KOH, it is basically replacement of Br by OH. And when you use alcoholic KOH, it is removal of HBr. Now here from double bonds, you are getting another double bond. So double bond is still there. Now if you use aqueous KOH, you are getting 2 OH group. But after that you have sodium amide, you have sodium in liquid ammonia. But this is when you have 2 OH group, it will not work with the further reagents. So it cannot be aqueous KOH, it should be alcoholic KOH. So when it is alcoholic KOH, there is removal of HBr, and you are now getting that is 1 hydrogen will be any of this hydrogen you can remove. It doesn't matter. So H, okay, put it. So you still have one H and one Br. Now when you have this type of vinylic bromide, now you need NaNH2, which is stronger base. If you want to remove another HBr, so again HBr will be removed and you will be getting this H and this C removed. You will be getting CC triple bond. And we know when we use hydrogen Lindlar catalyst, which is compared to hydrogen in presence of normal platinum palladium, Lindlar catalyst, its unique point is it will stop the reaction at double bond because of its poisoning effect. There is some poison added, so the catalyst activity is decreased. So you will get double bond from triple bond, not alkane. So Lindlar catalyst. So bromine first, then alcoholic OH. So that means in either option 1 or 2. Then NaNH2, and then hydrogen Lindlar catalyst. Do not choose sodium or liquid ammonia because that will be giving you trans. So these should be matching. So the last one is Lindlar catalyst. Okay. The major product A and B respectively are, this side we are using cold H2SO4, this side we are using hot H2SO4, 80 degrees. So when it is cold H2SO4, as if it is simple addition of the H and CH3, sorry, H2SO4, if you break it in two parts, it is H and HSO4 minus. So it is simple addition of H and HSO4 minus. You can also write it as OSO3H, same thing. So when it is according to Markovnikov, this part will be added here. That means your product should be either option 1 or this one, not option 2 or 3. So this should be the structure of A. You can cancel 2 and 3. But what will happen in presence of H2SO4 and 80 degree? So first, in presence of H2SO4, there will be protonation. And the protonation will be taking place in such a way so that you can get a stable carbocation. So this is the stable carbocation. Now this stable carbocation, it will react with another same molecule. So as if this is our electrophile and this is our nucleophile. So this will be added to this side and now you will be getting Me3C. That is, this total part is Me3C, then CH2, then C plus. This carbon will be having this positive charge. And finally, you have in the medium O minus SO3H. So this will be taking hydrogen from here and you will be getting a double bond CMe2. And this is the structure Me2C double bond CH CMe3. So this is matching with this one. It is not matching with because we have already cancelled these two. So among 1 and 4, correct option will be option 1. Okay. The one giving maximum number of isomeric alkenes on dehydrohalogenation reaction, excluding rearrangement, that we have to find. So maximum number of isomeric alkene, all these compounds are basically bromoalkane, isn't it? So just write all the structures because without drawing structure, you will not be able to understand maximum how many different types of alkenes you can, probable alkenes you can get. 1 bromo 2 methyl butane. So this is one position, sorry, this is 2 methyl. 2 position there is methyl, 1 position there is bromine. Now here, this is alpha position, this is beta position. You have only one type of hydrogen. So the alkene that you get is only one type. So this is not our correct. Okay, let me first finish all. The 2-1 is 2-bromopropane. So this is the structure of 2-bromopropane. Both sides you have similar type of beta hydrogen. So maximum product you can get should be like this propene. Come to 3, 2-bromopentane. So this is the structure of pentane. 1, 2, 3, 4, 5. So this is beta position, this is also beta position. Now two types of product you can get. If you remove the left hand side beta hydrogen, this is structure. Another structure possibility is this one. So here we are getting 2, unlike the previous 2 options. What about the last option? 3,3-dimethyl pentane. First draw pentane. This is 3 position, 2 methyl groups, bromine. Now this is beta position, this is beta position. But in the left hand side beta position you have hydrogen, but here you do not have any hydrogen. So only one type of alkene maximum you can get, which is this one. And we don't have to consider reaction. So except 3, in all other cases you are getting just 1. Only here you are getting 2, isn't it? So that is why 2-bromopropane should be giving you maximum number of alkene after dehydrohalogenation, that is after removal of HBr. Okay. So that's all for this. Thank you for your